Okay, so now coming to the question 2 of our cloud architecture interview series. The question is basically, so again, this question is from kind of like for understanding the overall concepts. Okay, and most of these questions generally lead to a follow-up questions and discussions. So basically, I asked these questions, and I have also again been asked this kind of a question, not exactly this, but kind of like this. So what do you mean by SLA for an application hosted in Azure? What is the impact of an SLA for an application which uses multiple Azure services? What do you need to discuss with customers or clients on this aspect before taking a decision? How it is related to your role as an Azure architect. So basically, see, as an architecture or cloud architect, you need to design solutions that are highly available, resilient, fault tolerant, and stuff like that. All of those well architected frameworks and stuff like that. So, what is an SLA? Okay, so SLA is a service level agreement which tells you that okay, my service will be up for this amount of time. So, for example, let me show you something. So, if you see this one, yes. So, when Azure says that this service, say for example, a service ABCD in Azure has an SLA of 99%, what does that mean? This means that Azure is saying that within a year, this service will be down for 3.6 days. Okay, within a year, this will surely, I mean, this could be down. And if it is down for that time or less than that time, you cannot say anything to Azure because Azure itself is saying that this is the SLA of my service. Similarly, for services which have 99.9% SLA, Azure itself is saying it can stay down for 8.76 hours. What if it is down for more than that? Then you can ask for service credit. So basically kind of like payback in, I don't know, maybe I have never done this with Azure ever, but the idea is that, for example, a portion of your bill is forfeited. Okay, something like that. But these are SLAs for Azure. So as a customer, when you are using an Azure service, this is the SLA of an Azure service, nothing else. Okay. But what about my application? So I have an application that say uses 3-4 Azure services. Now the client is not directly interacting with Azure, right? The client has paid me to design the architecture, design the application. So now my application also has an SLA. Okay. So say for example, my client is saying that this application should not be down more than 2 days in a year. This is the maximum I can allow. Okay. So then you need to calculate, okay, this is the application SLA that is requested by the client. Then you need to see that whether your services, the services that you have used, whether using them, you can meet that SLA or not. If you can, very good. Then you can confidently tell to the client that at least from an infrastructure perspective or from an Azure platform perspective, you are okay. Okay. Obviously, the application code can also fail. Okay, so that should also be part of your overall SLA. So if my code fails, say there is a null error, my application will again be down. But I'm not considering the application level failures here. I'm at a cloud because it's a cloud architecture question. I'm at the cloud or the platform layer. So the idea is very simple. This decision is driven by your client requirements. If, for example, a normal application which does not, which is a application which is not used that much, it is not that much critical, then you don't need a high SLA because maybe the owner itself is saying, the application owner or the client or the user is saying, okay, I am okay if this application goes down. I have a workaround. I can do something else. Say, for example, um, a read-only application. So if you cannot use that application, there is some other way, maybe a little bit more complicated or convoluted way, but at least you can get the same data. Okay. So in those cases, there makes no sense maybe to create a very complex architecture which provides you a high SLA, because the higher the complexity and the higher the availability requirement, the more complex it is and the more costly it also becomes traditionally. Okay, because you need to introduce more aspects both from an application programming, designing, and also from an Azure services perspective or AWS. And this concept is cloud agnostic. Okay, this has nothing to do with Azure AWS. The concept is the same. So for example, here you will see something is written here. One second. See, Everything else being equal, higher availability is better. But as you strive for more nines, the cost and the complexity grows. An uptime of 99.99% translates to about 5 minutes of total downtime per month. Is it worth the extra complexity and cost to reach 5 nines? Is it worth it to reach, for example, 5 nines where it is 5 minutes downtime? Because it is not simple to achieve. Okay, it's very difficult to achieve. So this is something you have to understand. Now, another part, what you have to understand, that individual Azure services. Okay, so let me go here. Will have some SLAs that is provided by Azure itself. Say, for example, app service web apps have 99.95, and say, for example, an SQL database has 99.99%. Okay. But you have to understand what is the SLA of your application. So you need to understand and consider the composite SLA, which is important for your perspective. What is a composite SLA? Because you have to tell your client what is your SLA for an application. The client is not interested in what is the SLA for an app service, web app, or an SLA. Client is interested for the SLA of the entire application or the system as a whole. So what is the maximum downtime you can expect for this application? If either service fails, the whole application fails, because both are implemented. If my app service web fails, my application front end goes, everything goes, pricing goes. If my database fails, no data, everything fails. So the probability of each service failing is independent. So at some level, I don't know whether this is a completely correct statement. Maybe it can happen that both of them are dependent on Azure Service Fabric, and so if Azure Service Fabric fails, both fails. But again, let's not complicate at that level. But the probability of each service failing is independent. So the composite SLA for this application is multiplication of both. So 99.95 into 99.99, which is 99.94. This is lower than the individual SLAs, and which is not surprising because application that relies on multiple services are more potential failure points. So the more services you include, the more chances of failure that you increase, right? That is why the composite. So there is a very good link here also, where for example you have an application, okay, which uses an app service, an Azure AD B2C, an Azure application gateway, and an Azure SQL database. Each of them have their SLAs that you can see in this SLA summary for Azure services. So for example, let me go here. So API management, you can see all of the SLAs for different tiers, different SLAs. So what is the total uptime? So you can see if any of the services that comprise our application are not available, our application will not be available for users to sign into and use. As such, the total uptime for application consists of the following, which is the multiplication of all of the uptime. So this is the SLA based expected availability of the application with the current service and architecture. And this is something you can go and tell to your client that from a platform perspective, this is the platform SLA that I can provide. I cannot provide better than this at this level unless I include more complexity. But at this level, this is what I can do. But say, for example, like I was saying, that this is not enough. So how you can improve? You can improve SLA by adding redundancy, by adding fallback paths. For example, here, after a web app, say you give an SQL database and a queue. So if your SQL database is down, say that application will still be up because there is some other processing that is happening in the queue. It will give some sort of message that okay, your processing is in a queue or something like that. So basically now what is the SLA? So in the earlier case, the overall SLA was 99.94, but now it should be better than 99.94. So I will show you what is the composition, 99.95, something around that. So the overall SLA has improved. Okay, why? Because you have added a new path in your architecture, but it has increased the complexity. So as you can see, there are trade-offs to this approach. The application logic is more complex. You are paying for the queue, and you need to consider data consistency issues. So it is not as simple as it looks. Okay, so there are trade-offs to this approach. And how I calculated this? So for example, my SQL database, okay, is up 99.99%. What does that mean? This means 99.99 by 100. This is what is the uptime. Okay, so if I subtract it, so this is what is the downtime, expected percentage of time where it will be down. So 0.001 for the SQL database and 0.001 for the SQL database and 0.001 for my queue. So this multiplication gives me the expected downtime of this part. So if I deduct with from 1, then this is this 99.999999%, this part is my SLA for this part. So SQL database or queue, this is the SLA. Now for the entire application, I need to multiply with the web app SLA. So this is my web app SLA 99.95, and this is my SLA for the other part 99.9999%. So this gives me 99.95%. So this is very important to understand, and this logic is very important, so that you can talk to your interviewer about this concept, that you are aware of this, you think about this when you design architectures. This is something that you consider at least. Okay, say for example, another thing I will show you here, okay, is that, say here, 1 second, so I have an application and the customer requirement is that it should be 99.9% available. What does that mean, 99.9% available? So if in a year I have 365 into 24 into 60 minutes, my SLA is 99.9%, right? So it is basically 0.999. So my downtime is 0.001, right? This is, now if I multiply this with 365 into 24 into 60, what is coming? So let me do this. I have 0.001 into 365 into 24 into 60. So I am getting 525.6. This is for the entire year. Now let me divide by 52, which is for a week. So I am getting 10.1076. So this is basically, so as I told you, so 10.1 minutes. So now say for example, they have two VMs in the design, one SQL load database and one Azure load balancer. So now this is the kind of SLA. Now there is some differences, that for example Azure SQL database SLA is also depending on the tier and stuff like that. But anyways, let us consider that this is the SLA. So then the composite SLA is 99.78%. Okay, so you have two VMs, 99.9 into 99.9. Then you have one Azure SQL database, and then you have an Azure load balancer. But in this case, this is not acceptable. So as you can see, this is not the composite SLA of 99% does not meet the required SLA. So how we can do it? So one of them is we can increase the SLA by using the better disks, because the SLA of the VM is also dependent upon what type of disk you use, whether standard HDD, standard SSD, premium SSD, or ultra disk. Also based on tiers and stuff like that. Here, one of the ways you can is that you can build availability requirements into your design. So here what we are doing, we are deploying 2 or more instances across 2 or more availability zones. So as soon as you do that, the virtual machine individual SLA rises to 99.99. So here you have 99.99 into 99.99. So it becomes 99.96, which is greater than what is expected. Okay, so basically the idea is very simple. Okay, is that to ensure high availability, you either use those components which are in itself providing a little bit of high availability, or you design your solutions to be redundant and fault tolerant. Okay, maybe you can deploy them across multiple regions. Okay, or even within a single region you can have some failback mechanism or graceful failures, exponential backup methods and stuff like that, so that your application as a whole is highly available, and even if there is a failure, it's not like that apparent to the so another very important thing that is mentioned in many of the Microsoft documents is that performance targets above 99.9% are very difficult for humans to achieve, because an SLA of 99.99% means 1 minute of downtime per week, which is huge. It is difficult for humans to respond to failures quickly enough to meet SLA performance targets above 99.99%. In those cases, your application must be able to self-diagnose and self-heal, because if a human intervention is there, 1 minute, it will obviously be more than 1 minute downtime per week. It will take even to read the issue, it will take a lot of time, right? To respond, your operation team responding, assigning engineers, it will take a lot of time. So here another thing that I want to show all of you. Okay, So another some things that you want to maybe also note, and I will do sessions on that also, is stuff like what is Mttr, what is Mtpf. So Mttr is the mean time to recover, average time it takes a system to recover or a component to recover after a failure. What is the Mtpf? It is the mean time between failures, the time a system can reasonably be expected to be up between two outages. So mean between two Mttrs, meaning between two failures, that is the time. So you want your Mttr to be as less as possible, right? You want to recover as quickly as possible, mostly via automation, via self-healing and stuff like that. And you want your Mtbf, mean time between failures, to be as high as possible. You don't want failures basically in a system. Similarly, you have RTO, RPO. Another very important thing is that not all flows in your system or not all components are as critical. Okay, maybe your payment system is critical, but your something like a chatbot is not that critical, maybe. Okay, so it is very important that you understand critical system flows is vital to assessing overall operational effectiveness and should be used to inform a health model. It can tell if areas of applications are over. So critical subsystems or passed to the application may have higher expectations around availability, recovery, and performance due to the criticality of the associated business scenarios and functionality. Okay. But some less critical components or path to the application may have lower expectations around availability, recovery, and performance. Less critical components can result in cost reduction by choosing lower SKUs with less performance and less availability. So this is one another important part, understanding SLA, as you already know. So the Azure SLA also includes provisions for obtaining a service credit if the SLA is not met, along with specific definitions of availability for each service. Composite SLAs I have already mentioned. What is the SLA for multi-region deployments is very important, that if you increase your regions, okay, so for multi-region deployments, the more regions you deploy, your SLA increases to some extent, right? So for example, the combined SLA for 2 regions is this, but the combined SLA for 4 regions is this. But you also need to consider that in multi-region deployments, typically you will have something like an Azure Traffic Manager. So for example, SLA for multi-region deployment involve a high availability technique to deploy the application in more than one region and then use Azure Traffic Manager to failover if the application fails in one region. But this failover, okay, this failover for active passive configurations is not instantaneous. So this also has some sort of a downtime. So you also need to consider the SLA of your traffic manager. If your traffic manager is down, your application is inherently down. So the idea of the question was not again to go into specific services with which you can create a high available architecture. That is not the purpose of this specific question. The purpose is more to understand how you think as an architect, whether you consider this in your overall design. So this is a good to obviously consider for your applications. Many of the times, for example, when I for most of my time working with clients, for some simple application, nobody even bothered. They even we have never, most of the deployments were single region within an availability set. We did not even deploy across availability across VMs or across availability zones, nothing. So they were very simple deployments, automated deployments. We did it, we gave it. If the application went down, maybe sometimes it's also okay, no issues as such. But then there are some critical applications. I once worked on a critical application which has a huge level of redundancy. It was a multi-region deployment. The entire database was a SQL always on cluster with active passive failover. Front I had ARR load balancers. So there was redundancy at every level. So such an application will have a high availability because it's a critical application. Requirement is very critical. So think in that way. What is the SLA? Do your client know? Can you document it? So for example, here you can see there was some mention. So get agreement from your customers for the availability targets of each piece of application and document it. Otherwise, your design may not meet the customer's expectation. We don't do this a lot, very frankly. Okay, we don't do this a lot, but at least at some level, something needs to be documented. So they should have that understanding that even though they are in the cloud, stuff will fail, okay, reasonably fail, and they should be okay with that at some level at least. Obviously you will try to improve as much as possible, but some failures can happen and they will happen, and what can happen will happen, it will happen. And your application needs to be robust enough to respond to them. But then at the level, if the platform fails, so you tell your customers that if the platform itself is failing, then the top players will always fail no matter what. And to give more redundancy and to break out, obviously there are application level logic you can write, failback paths, but also at the same time multi-region deployments, which will increase your complexity and cost also. Okay, our overall deployment complexity and everything will be high. But anyways, so this is the idea that you need to consider. Thank you for this. I will share your comments, please.